So I'm Jan. I'm CTO at Productive, and I will be talking about how we used AWS, its infrastructure, its services, to increase the scalability and stability of our application. So just a few words about Productive, who we are and what we do, so that you have a better idea of what we're dealing with. We are a product company, so our product, called Productive, is a software as a service tool which helps digital agencies like software development companies, like design studios, consultancies. We help them with running their business, with running their operations, in a way that we give them features like sales pipelines. We handle invoicing, billing, reporting, and stuff like that. So we were founded 5 years ago. We're based in Croatia, in Zagreb. At the moment, we are a 15-people team. We have more than 250 customers from all over the world. And we are growing quite fast. We're growing at around 50% month-over-month rate. So our customers are all over the world, but mainly they are mainly in Europe or in the US. So I first want to take you a little bit back in time, like 5-6 years ago, to show you how we started. And then I will take you step by step to where we're at now. So we started as usually startup companies do 5-6 years ago, with building our application ground up. So we just added features to our application. We built more stuff, and we ended up with a monolith. It's like a word that I heard a lot in these two days. So this is me building the monolith. This is my CEO and his dog Eric watching me build the monolith. But then you evolve as a company, you evolve as developers, you learn new things. And our next step was basically to turn things into components, which means that you basically just rename things and move them along, and then you think you're better. But you still have a monolith. It's just like a modular monolith. And after that, you learn about microservices. You learn about Netflix is probably the most vocal company about that. So we all know their famous diagram of how what this is, how their network of services looks like. And then if Netflix is doing that, if other companies are doing that, we should probably do that. That's like the new thing. So we started creating services, moving things into services, and we ended up with something I call the pseudo microservice model monolith, because in the end, in my opinion, there's no this is better than monolith. Monolith is better than microservice. I think my opinion is that in the end you're always going to be using both things, and this is our case. So let's call it the center of our product, our core API. It's basically still a monolith. It's big, it's huge, but whatever we could, we took out from the monolith. All these things that had a purpose to fulfill, that could live independently, we decoupled from our API. We created a service out of it, and basically this is something we have now. I usually joke it's like you have like a sun in the middle and then all the planets. So it's an apicentric theory, and I think that all the companies basically should go through this transition period of doing this way. And okay, that's one thing. That's like the model of our application. But I want to talk more about what's behind. So what's our infrastructure for running that. Our first AWS setup, we were talking about 2-3 years ago. So we had setups before AWS, but I won't talk about that. Our first AWS setup, from my today's standpoint, it was really simple. It was like one big machine, EC2, and everything was on that machine. So our API, all the services, everything was on one machine. Even the database was on the same machine. Our queuing, our caching, everything was on the same machine. Nginx was routing the requests. Passenger was running these applications. And honestly, it was really nice. Everything worked. The latency was minimal, like, access from the application to the database, there wasn't latency. And basically the only problem we had was scaling. So as we grew, we just kept scaling vertically, which means that we provisioned bigger machines. So we went from a medium machine to a large machine, from a large to X large. And we knew that that's not going to work. So we needed something else because we were hitting a wall. Then we started planning our like next architecture. And we set up these goals. So these were the goals that we wanted to achieve with our new architecture. So we wanted scalability, which means that we can handle 200 customers, 2,000, 20,000 customers with the same architecture that just scales. We also wanted isolation, which means that all these services are independent. So if one service breaks, it doesn't affect the others. We had problems in our old setup. You can imagine everything is on one server. One application goes haywire, uses RAM, uses CPU, everything goes down. So isolation was important. Stability, redundancy, so that each service by itself can handle like increased loads, can handle failovers. If something goes bad, it has like a redundant copy of itself. Consistency, we had problems in the past where you have like different environments. You have your production environment, you have your staging, pre-production, whatever. And it's really hard to make them as similar as possible. We usually want to make them identical, just with other configuration. We wanted to achieve this here so that we can have like a pre-production, which is identical to production, where we can test things and be sure that it's the same as our production. And also repeatability, basically the same, where we can easily just do a copy of our whole system, test something, change something, and remove something really easily. We ended up using a lot of AWS features. Most of these were mentioned in last 2 days, and basically the current state of our architecture looks something like this. So everything, all the requests come through our load balancers here, and they are routed to one of the services, which all the services are running on Fargate that Alan mentioned. And our API is not on Fargate. Our core API is still on EC2, but they're together inside the container service. The reasons for that, I will talk about it later. Also, our databases are here. We have like master and slaves for like writing and reading. Our caching system is here on a separate machine. Our queuing system, Redis, memcached. We have an interesting setup with running jobs with CloudWatch events and Lambdas. I will also talk about that later. And all our front-end code, like assets, images, scripts, everything's in S3 buckets, which usually have a CloudFront in front of the bucket, like a CDN. And here also we have some crazy stuff with Lambdas. I will also show you some examples. So the road to get from okay, we want a new and a better architecture with all those goals, to getting there, it was like crazy. It was like bumpy, curvy. It took us over 6 months from planning to execution to where we are at now. And I want to show you some fun stuff that we did, some interesting things we did, and also some problems we had along the road. So, first thing that we did, so when we were just talking about what should we do, this was still a black box for us, but we knew upfront that we are going to be introducing a lot of new things, a lot of new components, and that these components have to talk to each other, there will be latency, and we knew that we were probably going to be sacrificing speed to achieve scalability and all those other goals, but we didn't know how much. We didn't have a number. So what we started to do, we started to measure, test, measure, and compare. We created two parallel systems. So we had our old system, and we created the new future system, and we started routing parts of the traffic to the new system. Then we measured, we compared the results, we tweaked. So we changed the Fargate instances from medium to large. Then we did another round of testing. This approach really helped us to build our architecture, let's call it optimal for our usage. But it also helped us in the whole process of migration, because moving from some terms were mentioned, like lift and shift. We tried to do this step by step. So and this approach really helped us, because we just, for example, we took one service, we took our mailer service, we created a new one, which meant also Dockerizing it, which meant changing a lot of code, like a lot of things. But we created a new service on our new system. We started routing traffic there. We checked everything's okay. We routed more traffic. This way we also tested scaling up and down. Then we actually just moved all the traffic there and killed the old service. And this way, one by one, part by part, we moved everything to the new service. I mentioned Fargate. So our initial idea was to move everything to Fargate, because, as you already heard, Fargate is really nice. I call it a plug and play. So you just provision, you just say, I need 10 tasks of this size, CPU, memory, and you just have them. You don't have to care about provisioning. You don't need to care about updating, nothing. And we did that. We moved all the services. The problem that we had is with our API, where whatever we did, whatever we tried, for example, we took 10 medium EC2 instances scaled, we took 10 Fargate instances of the same size, same CPU, same memory, and the results were around 20 to 30% slower. So everything that was going through Fargate was slower. We're still not sure why. Is it because of Fargate? Is it because of that there's different networking behind Fargate, or it's just more complex? But we moved all the services which are not like that strict in response time. So we don't care if an email that we are sending in the background takes 200 milliseconds or 250. We don't care. But if our core API, which is responsible for everything, which is doing around, 5-6 million requests per day, is slowed by 20%, that's like a big hit. And we just couldn't live with it. So our API is still on EC2, but it behaves the same way. It scales up, it scales down, it's together inside the cluster. We just have to do more manual things. So when I'm talking about scaling, for me, scaling was the most fun and most interesting thing, and I would say beneficial for us, because if you think about the load profile of your application, so how your requests are going up and down during the day, week, or whatever, it really depends on what your application is and who your customers are. For us, as we are a B2B product for businesses, usually working hours during the day are correlated with our load during the day. So, for example, during the night or during the weekend, or when people are not working, the loads are quite low, and during the workday they go 5-6 times the values. So, auto scaling for us on all the services and especially on the core API was really beneficial. We go from running 2-3 machines during the night up to running 15-16 machines at a moment during the day, and everything is like scaled up and down. We also have like some notifications we are receiving. So just in terms of how many resources or money we would be throwing away if we just ran, 15 machines all the time, it's like a huge difference. This is also one thing that we had to solve in our new architecture. Like, we do a lot of jobs in the background, so I don't know, sending daily emails to our customers, weekly emails, or just checking some stuff in the database. I think we have around 20 or 30 jobs like this. So before we just had cron, which we easily set up to be running in specific times or intervals, and the cron was just invoking jobs really easily. But here, with all these machines scaling up and scaling down, there's no place to put cron. So we found an interesting solution with Amazon CloudWatch events, where you can basically the same way you do with cron, you just define like intervals or specific times when these events are going to be triggered. Then you connect them with a Lambda, so you call a Lambda, and then the Lambda creates the job in our queuing system. So like this works really nice for us if you have a similar problem. I think this is the way to solve it. One more interesting usage of Lambda was for app routing. So when you go to app.productive.io, you get the application in your browser. But we actually have two versions of our application. We have a stable.productive, which is what production is. It's like a stable version. But we also have like a latest canary, whatever, version of our application, which we give to a group of users, which like 10% of our user base are always using the latest, which is also, let's call it stable production. It's not like we're testing things there, but we're just releasing features first to the stable for a few days and then moving them to production. And we wanted to have a nice way to do this, that we don't have to say to them, yeah, use the other URL. Everybody uses app.productive. And then we have a cloud front and a Lambda, which, based on request headers, decides if the user will be given the latest code or the stable code. This also works really nice. It's easily, you can easily set up, you can easily turn it off and on, you can just change the rules and move more customers to your version or whatever. Okay, I also want to talk about problems we had. Most of our problems were database related. Well, actually, the database worked fine until one day, until July 25th, during the summer. Everybody's in vacation mode, and your application's not working. Nice. Where the load times just went crazy. Everything was like slow. It started in the morning, and it took us 4 hours. You can see up until noon to figure out what's happening. Our first, response was check monitoring, check the servers, check everything. Everything was fine, CPU, memory, everything. Then we figure out a catch that basically your input-output per second, your IOPS, you're provisioned for your IOPS depending on the size of the disk that you attach to your RDS. We didn't know that. We actually had a 100 gigabyte disk because our database is 20 gigabytes or something. So it was like a normal decision to provision a 100 gigabyte disk for 20 gigabyte database. which gave us exactly 300 IOPS, and we started hitting those. So we just got throttled. And as soon as we realized that, we just added more gigabytes to the disk, which is easy. And a good thing is that when adding gigabytes, you don't have downtime. Removing them is a problem, but adding is not a problem. As soon as we added more gigabytes, everything went back to normal. Read latency, write latency, everything. So we didn't know this. We learned it the hard way. So if you have problems, this could be an issue. Also, these are some AWS services that we're still not using, but are considering using, are planning to use. One of those is Aurora, especially because we don't want to think about disk size, we don't want to think about IOPS per second. We want somebody else to care about it. We want a database as a service solution, which I think that Aurora comes almost to that point. The only problem we have here is that we are using MySQL 8, and Aurora is still not compliant with MySQL 8, so we are waiting for that. I hope it will be resolved. Fargate, I mentioned Fargate. We're like fans of using Fargate. We are probably all the new services we are going to build in the future will automatically go on Fargate, but we're also hoping that we figure out the way, or something changes that we can move the API part to Fargate also, so that we just don't need to do those manual things. Lambdas also, we are using a lot of Lambdas. We have a bunch of new ideas of how we could use Lambdas and serverless in general. CloudFormation, like I heard a lot of discussion about is Terraform better, is CloudFormation better? We're still not sure. Most of the things we're still doing manually, and we just have to decide what to use. We'll probably go with the CloudFormation because, yeah, it's in the same stack, so we'll probably give it a shot. Also, Elastic Cache, we're still doing it the old way. So we have our EC2 server, which is running Memcache, and we handle it manually. Amazon has a solution for that. We're probably going to move at one point to that solution. The only thing that we have to think about is probably the pricing. So we have to figure out if it's maybe too expensive or not to use like a cache as a service thing. Also, Redshift as a representative of multiple AWS features which are used for analytics and reporting and stuff like that. Because we are doing all those things manually now. We are like writing complex SQL queries which are run against our slave database, or we are using third-party tools which tend to be expensive. So I think that it's like a normal future step for us to build something around Redshift and all those AWS features about it. This is where we're at now. So this is our current stack. We're quite happy about it. It works nice. It scales during the day and night, and we think that we have like much room for improvement. But for now, it works. In the future, we're probably going to be doing some more improvements, especially in the database part, because as you can see, so everything is scaled, but our database is not scaled, so it's basically a single point of failure still. So Aurora might be a solution where Amazon gives you like more room before you start doing more complex things like, you know, fragmentation, multiple databases, and stuff like that. So if you have any questions, any comments, if you want to talk about it even later, just come to me and we can share some ideas. So thank you for the time.
Hi.
Hi.
It seems that you're running a pretty decent business application. So, did you at any point feel like Fargate and Aurora were constraining you with something, and you needed more freedom to tweak something, configure it, or was it working well for you?
Yeah, I would say in the contrary. It feels more free not to be caring about those things and those configurations. I remember earlier, when we even before AWS, we bought a barebone server, and then you have to think about millions of things. You have to think about configuration. You have to think about updating it regularly. Then you have the heartbleed bug. All these crazy things. And here, you just don't have to care about it. So for me, this is freedom.
That's what I wanted to hear. Thanks.
Yep. Thank you.